Hi, I'm Peter MacHarrie. I work with RTX, and we support the ESDIS EED project. And I'm going to be talking about enabling open and equitable access to earth science data. I think that there are a couple of new technologies that are useful in this area. One is called Data Lakehouse technologies. So we'll go over what those are and then look at some examples of how Data Lakehouse can be used to enable interoperability and access to earth science data. And then look at some additional trends in machine learning applied to data analytics to further support equitable access to the data. So a data lakehouse is infrastructure that supports the organization and access to massive data holdings, potentially across organizations. Has three main components. One, data storage, that is either internal to or external to the data lakehouse. And the data in these storage locations needs to be in a data lakehouse supported format. Second component is a data catalog that models all the data holdings in terms of tables and columns, and then maps those tables to the underlying data. And then lastly, a query engine that's typically highly scalable Hadoop or Spark framework. And the data lake accepts SQL queries from client applications and returns a result data set that meets the criteria of those queries. So let's look at a couple examples of queries applied to earth science data. You see here I have a data lake that has a number of earth science data products in it. One is the ClimeCaps product, which is produced by GESDISC. And this table contains all of the internal multidimensional arrays of the ClimeCaps products, defined as columns within a table, and then has information about where that actual data is located within S3. So what I can do is take a client application like a Jupyter notebook, and I can use that to submit an SQL query to my ClimeCaps table, and I can specify time range, a spatial area, and then other various filters, like I might want to filter out bad quality observations from the data that I'm working with. I submit that query to my data lake, and it will return the data that matches the criteria of the query. And in this example, I'm going to create a scatter plot. And this is the scatter plot of the native level 2 data out of the ClimeCaps products. I'm looking at air temperature at various air pressure layers and at the locations, latitude, longitude locations that I specified in the queries. So it's kind of a different paradigm from the typical way of working with earth science data, where I submit metadata queries to get a list of files back, and then I process the files. Here, I'm letting the data lake handle all the file processing, and I'm just returning the data that I'm interested in, specified by a query. So since it's using this query language called SQL, this query language has a capability called a join, where I can join multiple tables together in a result set from my query. So in this example, I'm going to use a table that I've created, which are the tracks of Hurricane Ida. So as Ida progresses from a tropical depression to a storm to a hurricane at various categories, I have a track of the time and the location of that storm. And I can use that in a query with the ClimeCaps data to just retrieve those pixels around the center of the hurricane as it progresses through time. So this is just another way that I think we can start to get at the interoperability issue that we see a lot within various different types of earth science data products. Another example, kind of wanted to give you an idea of, it's just not for one particular type of data product. This is a Go16 SST product produced by JPL. And this is an example of what the queries can do. I can generate kind of a statistical history. I guess we'd call it like a level 3 product of this SST product. So what I can do is get a weekly mean every 10th degree of sea surface temperature for this JPL product, and then retrieve the data that's plus or minus 3 standard deviations of that historical summary. So I can see that here and just pull back pixels or observations where the temperature is 3 standard deviations lower than its historical mean. Up here we see the temperature is a little bit warmer than the historical mean. So another capability that I think becomes apparent is this a capability to join the data between various products. So here in this example, I'm matching up SST from the Go16 products with temperature from the, or surface temperature from the Aqua ClimeCaps product. And I can see here that in this area, the Go16 temperature is about 4 degrees Kelvins cooler than what's being observed by Aqua. And here it's about 2 degrees Kelvin warmer than what's being observed. So I can kind of get at kind of the interoperability issue between multiple earth science data products. And so we can kind of start to get out that interoperability issue with the data lakehouse. And we do address user access issues by making targeted end user application portals available for specific types of data. But what if I'm a user that has questions that my portal can't answer? And I don't really have a data science background, so I can't really get at the data easily that my portal is delivering. What if I don't understand SQL or how to make visualizations? Well, there's some interesting new trends happening with the data analytics tools in that they're adding natural language models to these tools. And I'll just give you a couple examples using something called QuickSight provided by AWS. And so taking that same ClimeCaps data that we were looking at earlier, in this case, if I'm not a data scientist, I can start to just ask questions through this application to get a visualization back. that's meeting kind of the English language version of the questions that I'm asking. And it's not just climate data, so I can put lots of different types of data into my data lake. So here's an example of severe weather data from NOAA's storm events database that's been put into the data Lakehouse. And I can ask questions of that data, looking at what types of severe weather events have caused the highest deaths in the last 5 years. Then I can look at still other data. So I think an interesting portal, which is air quality, they did something pretty interesting, was to make their data available through an S3 bucket in a format that is usable by a data lake. So I could define a table for OpenAQ's data and then join it with data from the census. And then I can start to get at questions about what's the relationship between race and pollution, and do this in English without the need for a lot of technical support. And I have this table, but maybe I need it in a map. Well, I can ask the application to create a map for me. So I think with this tool, with these tools, we can kind of start to get at that, start to address that issue of equitable access. I think it's going to take somewhat of a change in the way that applications are currently developed. I think if we look at how we approach this problem of access, we kind of use this application-oriented approach where we have a need or a specific topic that we want to address, and we build an application. And the application is gathers data, develops some processing capability, and develops an interface. And we make those available to non-technical users. And I think there was interesting case of the state of Vermont at the last ESIP meeting, and they had 7 different data sets that they needed to consolidate into another portal. And I think with this application-oriented approach, we kind of we do make the data accessible, but we also kind of isolate it. And I think with a data lakehouse-oriented approach, what can happen is you can still develop those applications, but you move the data and the processing into this data lakehouse where it's a little bit more shareable between the applications. And we start to have this ad hoc analysis capability that may not be so easy to provide with specific targeted applications. So we've looked at a data lakehouse infrastructure and see how we may be able to apply it to many different types of data sets and across many different types of organizations. We've looked at some of the natural language processing capabilities that are starting to come up in the analytics tools, and I'm kind of hopeful that these might be something that we would want to look further into to address issues of equitable access. Thank you for listening.